So we have three roundtables where the idea is to have an open discussion, so feel free to participate and to engage with us about the topic of biosecurity in the first, biosecurity and data security in the first roundtable. Then we'll talk about the DNA Data Storage Alliance with the board and what you would expect the DNA data storage to do in the future, what it's doing, what is doing good, what is not doing well and should improve, and what are the important future direction and work groups we should set up, apart from the one that already exists, including biosecurity, which is quite recent, and the last one will be on commercialization of DNA data storage solutions. So we'll start with this panel on biosecurity with the three speakers of the biosecurity and data security session. So we'll talk about some of the topics we heard about this morning. And so my first question would be: we heard about the regulations, the discussions that are ongoing on biosecurity, both in the US and the EU, and maybe Sophie, you could explain us what's going on in the EU, and James in the US, and also if you have ideas of what's going on in other parts, because the US and the EU is not the whole world. Is there some initiative in Asia about biosecurity or other places in the world? Sophie, please. Is
that better? Yeah. So good afternoon, everyone. Thank you, Stéphane, for the question. Looking at the situation in the European Union, so I'm often asked, where is the initiative of the EU Bio Act even coming from? So we have to go back to 2023. The President of the European Commission, Ms. van der Leyen, who's the current one again, she's in her second mandate, she came out in September 2023 with her State of the Union and identified 4 key priorities for the future of the European Union, and one of them was biotechnology. And I remember calling the Secretary General of Europa Bio, which is the biggest trade association in Europe for biotechnology, and asking her, Claire, were you aware of this? And she was not. So, long story short, this really took everyone by surprise, including the industry organizations, and that made it a little bit challenging to respond, but of course we did. In early 2024, the European Commission launched a consultation to have a better understanding of what stakeholders were hoping that would be in the EU Biotech Act. And now we're in the situation where, for those of you who are not really familiar with the European Union, there are 3 main institutions: the European Commission, which has the power of initiative for legislation; the Council, which is represented by member states and has the ultimate decision-making power; and the European Parliament. So the European Parliament right now, as I said this morning, they are in the final stages of developing the first report on biotechnology and biomanufacturing, sending a very strong signal to the European Commission of what should be in the Biotech Act. And there is an article, Article 11, which is on biosecurity. There's been a lot of to and fro, but biosecurity is there now, and I'm looking forward to the vote on the 7th of July of this report, and I hope it will be there. Going back to the European Commission, so the timeline is very short. The European Commission does want to adopt the EU Biotech Act in 2026. According to my math, that's a few months away. This is a challenge because the level of expertise in the European Commission is quite thin. And that's why with the IGSE and with other stakeholders, we've been attending hearings to get the word out. And so one recommendation I would make, as I've made this morning, is please engage with whoever you can at the national level. You do have ministries of foreign affairs, more likely, maybe defense or health, who are working on this topic. Engage with IBIS, IGSC, whoever is relevant. And I would really recommend that this community put a statement out there so that the European Commission understands where you sit in terms of biosecurity. Because you do have the opportunity to shape the agenda and to be able to be an interlocutor, and, an active participant. So I don't know if I responded.
Yes, I just have a question on this. So biotechnology is very large.
Exactly.
You mentioned this morning that in the initial discussion, DNA data storage was not considered. Is it still the case?
I haven't heard it on the radar screen. That's why I would really recommend that you be very proactive, that you put out a one-pager with a bunch of logos. The summer is upon us in Europe, and we know that in Europe, we tend to go away and go to the beach for a very long time. So you do have a few weeks ahead of you to get this ready for end of August, early September, send it to the European Commission, and I think, again, drive the agenda, because we can look at this as an opportunity. We have a short time frame. They must be panicking on the European Commission side. I wouldn't want to be in their shoes. 2, expertise is thin, so help them, articulate the arguments and make it easier for them to understand where you sit, and the fact that you are on board for biosecurity issues, that they can count on you. And I think also just identify the extraordinary role that you're going to be playing in the bioeconomy and in the future, because this has become a very political debate, right? So we're equating biotechnology, whatever that means, it's because it's such a broad issue, right, with sovereignty, with competitiveness. So I think here you have the opportunity to be very vocal and to be very strategic.
Okay. So in the biosecurity work group led by James, we have already prepared a document, a position document. Maybe, James, you could comment whether this would be, probably we could push this document to the European Commission. There are a discussion between the US and the EU. There will be a meeting at the beginning of July where some of you probably participate. We will at Biomemory. And can you comment, James, on the discussion between what's going on in the US, what is the calendar, and what are the discussions between US and EU?
So it will not surprise anyone here to know that the new administration in the United States has decided to revisit the 2024 framework. So there was an executive order that passed that was issued May 5th that said we have 90 days to rewrite the 2024 framework. And in that executive order, it was paired with a rewrite of what they're calling dangerous gain-of-function research. So those two things were already sort of closer than I was comfortable with them being to each other. And so that puts the release of this new executive order at August 3rd. So they will be busy over the summer, not going to the beach, I hope. There have been a bunch of discussions inside the White House now. Actually, there's a phone call at 6 p.m. Because this week, apparently, they mentioned DNA data storage from the White House of their own accord to a bunch of people who are supporting them technically on this topic. And so there's a bit of a rush to help the folks who are writing this policy understand the implications for DNA data storage. But they're on a very compressed timeline, so the policy was fairly complicated to begin with, and they're going to totally revise and rewrite it by August 3rd. So again, same sort of call to action applies, which is reach out to folks that you may know in the executive side of the United States and help them understand the technology so that they can get the right balance on a revised policy. And all of the IGSC companies have been engaging as well, because we really liked a lot about the 2024 framework and don't want to see some of those things changed. And I should say, in terms of engagement between the US and the EU, there is some limited outreach by the US State Department around biosecurity for biological applications, not for DNA data storage. But generally, that is not a huge transfer of information back and forth, kind of separate policy processes.
So you mentioned during your presentation that it it would be a burden to screen all at the scale of DNA data storage to screen all sequences. So do you think there will be a possibility to convince either for the Biotech Act or what's going on in the US that DNA data storage is an abiological use, and there are ways to secure this differently by securing upstream the codecs or the way you encode to ensure that there's no risk? Is that a possibility, or are we too late already to convince them to remove the DNA data storage? In my view, it's really short, and I'm not really convinced that it will be possible not to screen, at least for the texts that are under preparation. What is your feeling about it?
In my discussions with policymakers, I've tried to keep things incredibly simple and say, if you operate a service in which you, on demand, will make whatever nucleic acid someone asks of you, you must screen that pool, full stop. If, however, you've structured your business in a way where the decision-making about what is in the pool is not up to your customer, then that should be considered a protected use case and should not be subject to a screening requirement. And that seems to land quite well. Okay. So I think that distinction is a reasonable one to make.
And you have the same opinion on the screening?
A lot of the work that we're doing at the European Union level is really directing the EU institutions towards the work that has already been done abroad. We are a bit concerned that the European Commission wants to go out and just regulate without inspiring itself from what's happened, and namely in the United States, UK, New Zealand, etc. So at IBIS, we've been working a lot with colleagues at the NSCEB, US State Department, to encourage this type of dialogue and to just take advantage of the best practices, the experience, and the takeaways, that have been developed over the years. So that's been really critical. We say to them, you want to move quickly? Fine, but you need to take into consideration what's already out there and build on that. And going towards this goal of having international standards, we need to do that through coordination, not through the EU leadership and then the rest of the world following. We've said we doubt that.
Just last question on this topic. Are there some initiative in the rest of the world beyond US and EU? What's going on in Asia, for example?
Yeah, exactly. So that's a really good question. In October 2024, ASEAN adopted a declaration on strengthening biosecurity and biosafety in the region. And so I've been in contact with ASEAN itself and then the member state countries to find out how they're actually going to be doing this. We work very closely with the Asia Center for Health Security, and they are leading a project, and we're partnering with them to be able to help countries really implement this and to engage with what's happening in other parts of the world. So I'm actually encouraging my ASEAN colleagues to link up with the EU and the United States as well, so that we're all moving in the same direction, and it can also support many ASEAN countries who are stretched in terms of resources and others, but I don't think they're definitely not the only ones, but also just to encourage them to implement this, because I think there's a great deal of commitment and enthusiasm around it.
The second topic I would like to discuss is what's the point of screening the sequences for a number of reasons. The first one is, if it's centralized, okay, you can screen, but if it's decentralized, you order benchtop synthesizers from any company. Even if there's a software, you can imagine that any software can be hacked or the machine can be modified, and anybody, that's my feeling today, anybody can do forbidden sequencing if he really wants to do it. And we heard about the spying of such a machine that could get the data out and understand the sequence. Can you explain us what you mentioned very rapidly during your talk, because this is a bit frightening.
Yes, so during my talk I mentioned an attack that consists in spying on the DNA synthesizer And how it works is that you place a smartphone in proximity to the synthesizer, and it listens to the noise that the synthesizer makes, and can recognize the specific noises that the synthesis of a particular nucleotide, so A, C, G, or T makes. And so how the team that worked on it did it is that they trained the algorithm on a synthesizer that they had in their lab, and made it learn. It's an AI algorithm that learned the specific noise patterns, and it wasn't perfect in the studies that they showed. They had an accuracy of 88%, I think, but still it's really impressive.
Still not so bad, 88%. And so about desktop synthesizers, is it a problem that if anyone can print DNA in its own lab, finally, would these regulations that are in preparation would be effective or efficient? James?
I think generally what we have said have been two things. One, none of this is supposed to be, and I mentioned this in my talk, a complete bulwark against misuse or acquisition. So the goal is to make it hard and annoying and to require extra technical skills to do some misuse. So in that light, the benchtop synthesis companies have been really active in supporting a couple of different models. So one of those models has been the device has to be connected to the internet, and before it makes something, it sends a request, which gets screened, and then permission comes back. Some companies want to keep those devices entirely behind their firewalls and not expose them to the internet. The model that's been suggested there, although I'm not aware of any device that is on the market right now that does this, has screening on board. And the reason you generally put a human in the loop for screening is because they are false positive generators. So most of what the human is doing is saying, thank you for the warning, that's not that bad, it can go ahead. And so in the case of an unobserved device like this, it would basically just be annoying, and it would tell you no more often than maybe it should have. And can you circumvent those? Absolutely, but then now you need a hardware engineer, and you need an extra set of skill set. And so that still is in line with the goal of raising the level of complexity associated with acquisition and misuse.
Yeah, this kind of security is probably for unintentional generation of sequences. This would be very efficient. My feeling is that intentional misuse, you cannot prevent it. Somebody who wants to do harmful sequences will do them anyway. Okay.
And the goal is if someone really is interested in misuse, you want to force them to create as many signals as possible so that law enforcement has an opportunity to find them. And so you really want to push them into technologies that are not easy, that are not high throughput, that require extra skills, extra touch. And so that's part of the goal of the screening regime.
Okay. So we heard this morning about biosecurity, but also about data security. Is this, I didn't know a lot before about data security and how it could cause problem at every steps of the DNA data storage end-to-end systems. Are there many discussions in the field, maybe you know, or maybe James or Sophie, about not only the security of the DNA for biological reasons, but also about the data security and the dangers of secure data or confidential data that would be encoded into DNA. Is this something you consider at Twist, for example? Or do you have idea if there are other initiatives than yours in the world?
I think I know that in my team we are several people are working on this, and I know that there are other initiatives, but for now publications are a few. So I think maybe people are wanting to be really sure of what they are putting out before publishing, because it also could be patented, and so.
You mentioned another surprising thing about this sequence, that when sequenced would encode a computer virus that would infect the computer that is reading the DNA. Can you comment on this? And is there some specific measures that companies like Twist are using to prevent this?
So when this paper came out, I was asked about it quite a bit. The important thing to know about that paper is there was a supposition that the sequencer itself was compromised. And so the sequencer was compromised, there was a piece of malware placed on the sequencer, and then the sequence that came into that sequencer triggered the malware. It wasn't that the DNA itself coded for a virus or was itself malware, it was a trigger. And so I think that's interesting and fun and novel, but I don't necessarily see it as a significant threat vector. So companies like Twist, we do take cybersecurity very seriously. We're ISO 27001 for very good reason, right? Our customers are trusting us with their sensitive intellectual property. But I do think there's also something biotech needs to take more seriously on the insider threat perspective, which I think your talk did a great job of kind of highlighting the role that an insider threat could play. And biotech traditionally just hasn't really thought about that much. So I think that is room for growth.
One of the last topics I would like to discuss is AI. And we heard this morning that something that will be more and more feasible, that you could imagine using AI to get a protein that has the same function as a dangerous protein. Let's say you want a toxin, and you take a very dangerous toxin, but with the AI you can make the same function without the same sequence. So this will not be flagged by screening like the common mechanism of EBIS. So are there some discussions at EBIS, for example, or at Twist on how we could do this? And my view is it really a problem of DNA synthesis and DNA security or AI security?
So we just published a paper, IGSC companies and Microsoft, in which Microsoft built a protein engineering pipeline that tried to redesign a bunch of controlled toxins. And then those were passed through screening systems, including the common mechanism, including the screening system Twist uses. And the good news was that for sequences that had very low homology, such that we couldn't detect them in homology-based screening, the structure per alpha fold was significantly different than the wild type structure. And so the model is not good enough yet at maintaining that wild type structure while keeping homology extremely low. So that's great news, but that was protein MPNN, which is now almost 2 years old. So there isn't a process to take the model that came out last week or the week before and rerun this test. So we have no idea how fast these models are advancing in capability. And there isn't any, to my knowledge, if you all know, please let me know, there's no sort of white hat defensive hacking community around AI-based protein design, not LLMs, but AI-based protein design tools. And so from the DNA synthesis community perspective, we see coming down the road vast numbers of sequences that have no homology to anything in reference databases, and we simply won't be able to carry out risk assessment. And so we're really trying to engage with governments and say, like, this is an excellent opportunity for national security-based research funding to help solve this problem, to build defensive models. And so far, there has not been much uptake on that.
Similarly, in the field of cybersecurity, does AI pose some threats on all the aspects you mentioned this morning? Are there some discussion in the field of cybersecurity about how AI could make some breach in the security system that are in place?
Yes, of course. They're really entwined. I mean, I don't know if I could give some examples, but yes, AI and cybersecurity are really entwined in the team. Some people are working on how to secure AI and what AI can bring to cybersecurity. It's a bit less my specialty, but I know that it's really interesting to mix both. Yeah.
Yes.
Maybe I'll just add there is a community of folks in the protein design who are building the AI tools, who are trying to build defensive measures for restriction of access to their tools. That's sort of the prime direction in terms of defense. And of course, the open source community is sort of pushing back on that and saying, like, open source tools, you can't really control who gets access to them. And so that may not be a long-term solution.
I don't see it will be a very long time before we have a paper like the polio paper, but showing that I designed a toxin and I proved that it's a toxin, and it was, I ordered it and nobody didn't find it in the screen. Are there some discussion at IBIS about this future problem that will, I guess, emerge at some point?
There are definitely lots of discussions going on, and I have to say at the EU level, we're also taking the opportunity of the EU Biotech Act in order to work more with the AI community as well, to engage with them so that they don't go off and talk to the European Commission on their own, and then we have a separate discussion. We're really also trying to look at this from a governance perspective and try to get our house in order before we all go off and talk to the European Commission. Again, what's making this challenging is that we have a very tight timeline, but I think both communities understand that it's in our mutual interest in order to combine efforts.
Are there any questions about biosecurity from the audience? I don't really see you. Yes.
James, who has the voice in the U.S. government on response to the EO?
The lead agency in charge is OSTP, the Office of Science and Technology Policy in the White House.
DOE supporting, or are they?
There is an interagency that is supporting, so there's DOE, NIST, HHS, and a few other agencies, but OSTP is the lead.
Any other question?
Actually for Sophie. So in the EU, my recollection may be out of date, but computing and digital matters were handled by Digital Connect as part of the Commission. Is that where this kind of issue will be undertaken in the EU, or is it a different part of the Commission?
I wish I had an answer. So the current situation in the European Commission is that there are two Directorate Generals that are, I wouldn't say fighting, but they're vying for taking the lead for the EU Biotech Act. So as I sit here facing you today on the 20th of June, telling you that we're on a tight time frame to adopt the EU Biotech Act, we don't know yet who's going to be holding the pen. It could be DG Health, and a lot of people think that's a great thing, but they're pretty low on the food chain within the European Commission. So, and they have a, well, they have a reputation of being quite slow and not really engaging with external stakeholders. And the other one is HERA. So they deal with pandemic preparedness and responsive measures. We've been talking a lot with them. We really do hope to have an answer soon, and I think the people in the European Commission who will be working on the EU Biotech Act probably want to know whether they're working on it or not.
One last question on this. Where do the countries like Switzerland, UK, and others play in this, if at all?
So at IBIS, I have to say I've been engaging a lot with the UK. I like to present them as a best case. They have an extraordinary public-private partnership. They have a wonderful strategy that was adopted several years ago, a council, and so we've been bringing them along to hearings. I've been working a lot with Imperial as well because they just have an extraordinary track record of building a bridge between the research community and the policy community. So definitely the UK, Switzerland. I'm thinking more about the international institutions, but we're working within the Europe as a whole, as a bloc, not only the EU.
But the net of it is those countries are not planning to be under the umbrella of whatever law comes out of the EU. They're going to go their separate ways.
Well, the thing is, there are more and more, given the current geopolitical situation, the UK has moved much closer to the EU. We've kind of forgotten about the divorce, or we're over the bitter part of the divorce, and we're talking to each other again. And so there are more and more examples of partnerships, of research grants that are going towards the UK. And I do think that we can be quite confident that we'll be able to align our work in this area. I am an optimist, but then again, I'm seeing things that are reassuring.
Okay, I would like to thank participants to the panel. We'll close this panel now and shift to the next panel. And I'm sure there will be many discussion about biosecurity in the coming year. Thank you.